Hello everyone, good evening. So here we shall start from question number 6 onwards. So here it is given that ABCD is a trapezium. ABCD is a trapezium in which AB parallel to BC, BD is a diagonal, BD is a diagonal, and E is the midpoint of AD. E is the midpoint of AD. And a line is drawn. A line is drawn through line is drawn through E, which is parallel to AB, intersecting BC at F. Then we have to prove that F is the midpoint of BC. F is the midpoint of BC. So then we'll get the proof. So here we will say that let EF intersects the diagonal BD at the point G. So this point ends in basis G. This point is G, suppose. So then, so I will say now that EF is parallel to AB, which is parallel to DC, since it is given. And in triangle DAB, E is the midpoint of AD. E is the midpoint of AD, which is given. And EG is parallel to AD. So therefore, I can say that G is the midpoint of DB. G is the midpoint of DB by using the converse of midpoint theorem. By the converse of midpoint theorem, which states that if a line is drawn parallel to one side to the midpoint of another side, then it will also pass through the midpoint of the third side. So if I tell that this is ABC and this is DE, then if D is the midpoint of AB and if I draw DE which is parallel to BC, then E will be also the midpoint of AC. So this is the converse of midpoint theorem. So here G is the midpoint of BD, we have proved. So similarly, I will say now similarly in triangle BCD, G is the midpoint of BD. G is the midpoint of BD, which we have proved earlier or proved above. And also GF is parallel to CD. GF is parallel to CD. So we can say that F is the midpoint of CD, or F is the midpoint of BC. F is the midpoint of BC and by using the converse of midpoint theorem. By the converse of midpoint theorem. Of midpoint theorem. So hence proved. Then here in question number 7 it is told, it is given that in parallelogram ABCD, E and F, are the midpoints. E and F are the midpoints of the sides AD and CD respectively. AD and CD respectively. CB and E and F are the midpoints of AD and CD respectively. Then we have to prove that the line segments AF and EC, AF and EC trisect the diagonal BD. Trisect the diagonal BD. So here the proof is that the proof is here I will say in triangle ABP, E is the midpoint of AB. E is the midpoint of AB. Is given. And EC. So first we have to show that EC is parallel to AF. So it is a parallelogram. So first we have to show that this is AECF is a parallelogram. First we have to prove that. Okay. So we'll say that. So in parallelogram ABCD, you can say that AE equals to AB, which is equal to half of AB. Since it is given that E is the midpoint of AB. And similarly, FC equal to FD, that is equal to half of CD, which is given also that F is the midpoint of CD, and obviously AB equal to CD. Since the opposite sides of a parallelogram are equal, since the opposite sides of a parallelogram are equal. So therefore, I can say that opposite sides of a parallelogram are equal. So therefore, we can say that half of AB that is equal to half of CD, and also AB is parallel to CD since opposite sides of a parallelogram are parallel. Opposite sides of a parallelogram are parallel. And therefore, we can say that also half of AB means it is E. So A, half of CD means FC. So A equal to FC. A equal to FC. And so AB is parallel to CD means AE is parallel to FC also. So therefore, we can say that therefore AECF is a parallelogram. AECF is a parallelogram since one pair of opposite sides, since one pair of opposite sides in it are parallel and equal. Since one pair of its opposite sides, are parallel and equal. So now, therefore, I can say that AF is parallel to EC, AF is parallel to EC, and AF equal to EC. Or I can say that AF is parallel to EC. AF is parallel to EC since why? Since opposite sides of a parallelogram are parallel. Opposite sides of a parallelogram are parallel. So therefore, now therefore now in triangle ABP, in triangle ABP, AP is parallel to EQ. AP is parallel to EQ, and E is the midpoint of AB. E is the midpoint of AB. E is the midpoint of AB. Q is the midpoint of PB. Q is the midpoint of PB. Is the midpoint of PB, since by using the converse of midpoint theorem, by the converse of midpoint theorem, So therefore, we can say that PQ is equal to QB. Q is equal to QB. Similarly, in triangle DCQ, EF is parallel to QC. EF will be parallel to QC since AF is parallel to EC. And F is the midpoint of DC. 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 Therefore, I can say that P is the midpoint of PQ. P is the midpoint of PQ by using the converse of midpoint here. By using the converse of midpoint here. So therefore, I can say that dP is equal to PQ. Therefore, I can say dP is equal to PQ. So hence we can say that dP is equal to PQ is equal to QB. GP is equal to PQ is equal to QB. And also we can see that so dP is equal to PQ and dP plus PQ plus QB, that is equal to dB. So hence we can say dP is equal to PQ is equal to QB is equal to 1/3 of dB. And so I can say, and so the line segments AF and EC trisect the diagonal BD. AF and EC trisect the diagonal BD. So hence 2. Then here it is told in question number 8 that show the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. So if we draw a quadrilateral, suppose ABCD, and we join the midpoints of the opposite sides, then so this is AB, this is P, this is Q, this is R, this is S. So you have to show that they bisect each other. Bisect each other. So we have to show that there is a parallelogram. Then only the diagonals will bisect each other. So the midpoints. So here we can draw a diagonal AC. Can draw the diagonal AC. So now here is given that in quadrilateral ABCD, PQ, R, and S are respectively the midpoints of the sides, AB, BC, CD and DA respectively. Okay, DA and so we have to prove that the line segments joining the midpoints of the opposite sides. It means line segments PR and QS bisect each other. Now here we need one construction. Construction is the line segments PQ, QR, RS, and SP and the diagonal AC are drawn. Then we will write the proof. So now here we will see that in triangle ADC, S and R are the midpoints. S and R are the midpoints of AD and CD respectively, since it is given. So therefore I can say that SR is parallel to AC and SR equals to half of AC. Hence, by using the midpoint theorem, and similarly in triangle ABC, P and Q are the midpoints. Of AB and CB respectively. So therefore I can say that PQ is also parallel to AC and PQ equals to half of AC, which is according to or by using the midpoint theorem. So now therefore I can say that in quadrilateral PQRS, PQ is parallel to SR, which is parallel to AC. Since we have proved that both are parallel to AC, so both are parallel to each other also, and also PQ will be equal to SR, since both are equal to half of AC. So hence we can say that PQRS is a parallelogram. So PQRS is a parallelogram. Since one pair of opposite sides, in this quadrilateral, are parallel and what? Parallel and equal. So hence PQRS is a parallelogram. So therefore I can say that PR and QS. So therefore I can say PR and QS. These are the diagonals. The diagonals PR and QS in parallelogram PQRS bisect each other. Since why? We know that since in a parallelogram, the diagonals will always bisect each other. Since in a parallelogram, the diagonals bisect each other. So henceforth. So hope all of you understood till the question number 8. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. And please install our Sapience education application also, which shall be obviously helpful for your exam. So thank you everyone. Bye.